Hi, this is Brian Kim. I'm going to share with you this case of a patient who was referred to me. The patient had a dislocated three-piece lens within the capsular bag, and so I thought I was going to be very clever and perform a reverse optic capture of that same lens so that he wouldn't have to have an exchange, but you'll see that that was a major failure, and I'll show you how I handled that. So this is a patient, again, this is a lens that's within the capsular bag but dislocated. You can see there's a really fairly irregular but well-centered and round rhexis, and it's a little bit smaller than the size of the optic. So as I'm making my incisions, I'm thinking, rather than exchanging this patient, maybe I can just reposition this lens in such a way that it's going to be stable, kind of a quick and fairly elegant procedure. So go ahead and inject some dispersive viscoelastic into the anterior chamber. Again, I am preparing for any possibility for this lens, and so go ahead and put some viscoelastic in, make a small incision. Again, I'm hoping at this point not having to exchange the lens, maybe just repositioning the lens. So I'm trying to grab the lens with toothless forceps, and I realize this lens is made of silicone. It's not really grabbing very well. So I have to switch to the IOL holder, which has little ridges on it, and I'm able to hold it fairly nicely. And so I'm able to pop the optic in front of the rhexis, and so it's nice and centered. So I thought, man, this is great. So I'm trying to irrigate the dispersive viscoelastic out of the anterior chamber, which is working okay, but there's still quite a bit of viscoelastic still in the eye. And then I'm going ahead and repositioning the lens, because as I did that, the lens did come out again. And so I'm flushing some more. But again, it's really not working very well. I'm not able to get all the viscoelastic out. So I go in with my larger incision and go ahead and perform the mechanical irrigation and aspiration of all that viscoelastic. Again, if I knew I was going to just reposition it, I would have not put in all that viscoelastic. It would have saved me a little bit of a step here, but I wasn't quite sure, and I wasn't knowing what I was going to get myself into. And that's the thing with these procedures. You don't really know what you're getting yourself into until you get into the case. And so once I got into it, I thought, okay, I can reverse optic capture this lens, and that should be a pretty easy case. So again, I'm repositioning the lens, making sure that the lens is definitely in the reverse optic capture configuration. What I've noticed is, even though it's captured, the rhexis is just a little bit on the large size. But I go ahead and hydrate my incisions, and I'm hoping that this patient is going to do fine with that configuration. But unfortunately, the patient comes back 1 week later and the lens is dislocated again. And so I'm thinking about what to do with this patient. I explained to him the optic capture as well as the rhexis size and the optic size. And I think he's an engineer type, and he said, is there a lens that's actually larger than the optic that you have? And I would realize, oh, there is. I can try to use an MA50BM lens. Instead of the standard 6mm optic, that lens has a 6.5mm optic. And so my game plan is to, instead of do reverse optic capture, I'm going to remove this lens and then place the MA50BM lens in the ciliary sulcus with optic capture. So I go ahead and make my incisions. You can see, just looking at the rhexis, you would think it would be able to hold that lens, but obviously not. As I'm pushing the lidocaine, you can see the lens is dancing there, so it's really not quite stable. I'm injecting some dispersive viscoelastic to fill the anterior chamber, and I'm making my temporal incision. Now remember, I made an incision before, and this is about 6 weeks later. Because of the holiday, he waited to have his second surgery today, and so I'm making a second incision with my blade, but I'm going to plan on placing a suture anyway, so I didn't mind making another incision. I'm injecting some cohesive viscoelastic within the bag, to create some space between the lens and the posterior capsule. And with a two-handed technique, I'm using the two forceps to very carefully prolapse the trailing haptic up out of the bag. I pull the trailing haptic out of the anterior chamber, and then holding the optic with one hand, I'm going to very carefully lift the leading haptic up into the anterior chamber. And then while still holding the lens in the left hand with the forceps, I go ahead and cut the lens in half with the scissors with the right hand. And so again, holding still with the left hand the entire time with the forceps. Oh, and then I remember this is silicone optic. I'm not able to hold the lens with the toothless forceps, so I had to switch my forceps out because I only have one IOL holder. And since the haptic is already out, I don't have to pull that out again. You have to grab the optic at that pointed tip, otherwise it was catching on the incision there. And then pulling out the second piece. So I'm injecting some cohesive viscoelastic to fill the ciliary sulcus now. And again, this is the MA50BM. Instead of a standard 6mm optic, it's a 6.5mm optic. And you would think that 0.5mm is not going to make that big of a difference, but you'll see when I place this lens into the ciliary sulcus and then optic capture it, whether or not it's going to be stable. So I deliver that leading haptic right into the ciliary sulcus, right underneath the iris, but in front of the anterior capsule. I dial the trailing haptic in with the Maltzman. I go under the lens, removing the viscoelastic from within the bag. And then removing the viscoelastic in the anterior chamber. Once all the viscoelastic is out, I'm using the INA tip to pop the optic underneath the rexus edge in a buttonhole technique called optic capture. I first use a Sinskey hook to see if I'm optic captured there, and I can tell that it is optic captured there. The telltale sign of good optic capture, whether it's reverse optic capture or optic capture, is the V configuration with the capsule. And so you can see right where the haptic optic junction is, there's a V configuration of the capsule, and that means there's actually capture there because at the haptic optic junction, the anterior capsule is above the lens, and therefore it's causing this V-shaped configuration to the rexus edge on that side, as well as on the other side. And so when you have that configuration, you know there's enough tension there to stabilize and support that optic capture configuration and to keep that lens in a stable position. And that's the problem with the first case, and that's the learning point. When I had the reverse optic capture configuration, when I first did the repositioning, I did not achieve that V-shaped configuration to the capsule. And when you don't have the V-shaped configuration of the rexus edge, that means you don't have enough tension to achieve optic capture in a stable manner. So I'll go ahead and place that suture like I said, and bury the knot. And so you can see I have a really nice, well-centered situation here. I'm hydrating my incisions. And so again, that's the two learning points. Whenever you're performing optic capture or reverse optic capture, the rexus has to be in a V-shaped configuration at the optic haptic junction in order to have a secure optic capture situation. So I'm checking one more time with the Maltzman, and I do have a nice V-shaped configuration of the rexus there. And so that is, again, a very stable situation. This patient did quite well. He bragged to me that he was the one that figured out how we should stabilize his lens, and I gave him full credit for that. And I did tell him that, sometimes with these surgeries, it's not kind of a cookbook way of doing surgery. You have to think outside of the box and really get creative. And so we were able to do that, thankfully. So I hope this was helpful to you, and I thank you for your attention.